Now let's talk about parallel and perpendicular lines. So parallel lines, they run parallel to each other, meaning they never intersect. So as they go off to infinity, they never intersect with each other. So what this means in terms of our linear function, so f of x equals mx plus b, two lines are parallel when they have the same slope but different y-intercept. Different y-intercepts. Perpendicular lines are going to form a 90-degree angle where they intersect with each other. I'll do this as best I can. Yeah, something like this, where we have a 90-degree angle coming through. So they do intersect, but at a very specific angle measurement. -degree angle or right angle. So with this one, the rule isn't as simple. Y-intercept doesn't particularly matter. With this one, it's all about the slopes. So slopes are, so what you could notice is like what I drew here, one's positive and one's negative. That's going to be part of it, is it's going to be switching sign. So slopes are opposite, but then we're going to have one more word to put in here that changes the behavior of it, and the word is reciprocal. Okay, so slopes are opposite reciprocals. What that means is, like I was saying, opposite is going to be change the sign. So if it's positive, it's going to change to negative. If it's negative, it's going to change to positive. Reciprocal means switch the numerator and denominator. So we can say opposite reciprocal, but if you're looking for kind of a shortcut way to think of it, how I think of it is change sign and flip. Flip meaning switch the numerator and denominator. That's opposite reciprocal. Change the sign and flip it. So let's try this out. Here we have three slopes. We have a slope of 2, a slope of -4, and a slope of 2/3, and we want to find the slope of a line perpendicular. So basically practice finding that opposite reciprocal. So our original slope here is a +2. And what'll help is to think of this as a fraction. So this is the same thing as 2/1. Taking the opposite reciprocal, we're going to change the sign. So because it's starting as positive, our answer is going to be negative. Flip it. So instead of 2 in the numerator, 1 in the denominator, 1 in the numerator, 2 in the denominator. And that would be our slope of the perpendicular line. So a line with a slope of 2 is perpendicular to a line with a slope of -1/2 because of how that slope changes. All right, here we have a slope of -4, so I'm going to think of that as -4/1. So finding a new slope, because it's -4, we want to change it to positive, and then we're going to switch the numerator and denominator, so it'll be a +1/4. So we change the sign and flip it. And let's see, a slope of +2/3, taking the opposite reciprocal. So because 2/3 is positive, we want a negative outcome. 2/3, 3/2. Oops, 3/2. So that's the idea of opposite reciprocal. Change the sign, flip the fraction. So let's put this into practice of actually finding our full equations of lines. So we're given the line f of x equals 6 plus 3x. There we go. It's going to highlight it. Find an equation for the line passing through 3, 0. That is, we're going to find one line that's parallel, another line that's perpendicular. So original function 6 plus 3x, something that'll be helpful here is that we have a y-intercept of positive 6 and a slope of 3. So forming the parallel line, I want to use that same slope. So I want m equals 3 for my parallel line. What should happen is I should be changing the y-intercept. Now, in terms of forming my linear equation, y equals mx plus b, I have m equals 3. I don't know what b is yet. I don't know what this other y-intercept is. So to do that, I know the line should pass through 3, 0, so I'm going to plug that coordinate in. So 0 where y is, 3 where x is. So 0 equals 9 plus b, so b equals -9. So if I have the equation y equals 3x minus 9, that should be parallel and going through the coordinate 3, 0. Let's confirm that by graphing it in our calculator. So I'm going to go to the Desmos graphing calculator. I'm going to graph 6 plus 3x. So here's my line. Then I'm going to graph the second equation, y equals 3x minus 9. And what I should see with that line is that they're parallel, so they have the same slope, so they're never going to intersect. And then I just want to make sure that 3x minus 9 goes through positive 3, 0, which it does right there. So that's perfect. So our final answer is that y equals 3x minus 9. Okay, if we wanted something perpendicular, so our slope, the slope of our original function is a positive 3. So the slope to perpendicular, change, flip. So -1/3. So 1 in the numerator, 3 in the denominator. We start with positive, so this should be negative. So for our equation, we have y equals -1/3 x plus b. And we need to find b, and to do that, we're going to plug in the coordinate 3, 0. So we're going to have 0 equals -1/3 times 3 plus b. -1/3 times 3 is a -1. Add 1 to both sides, and b is going to be a positive 1. So our equation should be y equals -1/3 x plus 1. And let's go ahead and check that in our calculator. So -1/3 x plus 1. And you're just going to have to visualize this as best you can. It's kind of harder to see perpendicular lines, but roughly they should be intersecting at a right angle. And then for that equation I just typed in, I want to check that the coordinate 3, 0 is there. So this is looking fantastic. So that would be our answer for a perpendicular line. So parallel, same slope, perpendicular, opposite reciprocal slope.